These notes begin your Module 2 notes. This is Module 2, Topic 1, Lesson 1. The topic is Similarity. And before we begin, I would like to look at dilations, which we looked at in class. And here's an example of a dilation. It's either an enlargement or a shrinkage of the original figure. So A, B, C, D, this rectangle here is our original, and our A, B, C, D prime is our new. So if you had a scale factor of exactly 1, about 1 would be exactly the same figure. As the scale factor gets larger, bigger than 1, your figure gets bigger. It's an enlargement. Okay, 1.79, and it enlarges. If you go below 1, scale factor there, 0.63, the figure is going to be smaller. So if the scale factor is bigger than 1, it's going to be larger. If the scale factor is between 0 and 1, it's going to be reduced or shrunk. Okay? So let's look at our first example. Example 1. We have triangle ABC prime is a result of a dilation of triangle ABC with the center of dilation at the origin. What is the scale factor used in this dilation? And what is the ratio of similarity for the two triangles? So all of our dilations we do in this class, we use the origin, 0, 0, as the center of the dilation. So if we look at this, if I wrote down the original points, A is 2, 3, A prime is 4, 6. I want you to think to yourself, what would you multiply 2 by to get to here? What would you multiply 3 by to get here? 5 to 10, 1 to 2, 2 to 4, 1 to 2. What are we multiplying by each time to get there? Correct, we're multiplying by 2. So this actually has a scale factor of 2. We're multiplying our original by 2. So if I multiply 2, 3, right here, I end up getting 4, 6, and so on. It builds our new triangle. So that's our scale factor. Our ratio of similarity is going to be between the two triangles, ABC and ABC prime. And the ratio of similarity could either be done as small over large or large over small. You could also do it as the original image over the pre-image or the pre-image over the new image. So either way, they can be done for ratio of similarity. The key is you got to be consistent. So if I want the ratio of similarity, I know it's 4 over 2 or 6 over 3. That gives me a ratio of similarity 2 to 1. If I want to go 2 over 4, 3 over 6, then I have a ratio of similarity that'd be 1/2. Okay. Now we can see it in the figure. Here's my center of dilation. The distance from here to A, I wrote it down, is 3.6. So if I go from the origin to A, that distance is 3.6. As I went from the origin all the way to A prime, that's going to be 7.2. So you can also see the ratio of similarity here, or the scale factor as well. 7.2 to 3.6. 7.2 divided by 3.6 gets me 2 to 1. When I look at to B, I went from here to here, that was 5.1. And when I went from the origin all the way to B prime, that is 10.2. So again, 10.2 divided by 5.1 gets us 2 to 1. Finally, the dilation going to C and C prime, as I went from here to C, that was real small. That's only 2.2. So that's 2.2. And then went from here to here, actually from the origin to C prime. That distance is 4.4. So we have 4.4 over 2.2, which gives me 2 to 1. So when we talk about the scale factor is what are we multiplying the original by to get the new figure. We talk about ratio of similarity. We're talking about two similar figures, and what's the ratio of their corresponding sides. So if we look at the triangle here, ABC prime, if we just look real quick at just the legs, right? The legs of AC, that's 2. So how big should AC prime be? Well, 2 times 2 is 4. Let's see. 1, 2, 3, 4. It is. Look at the horizontal legs. CB is 1, 2, 3. So what should CB prime be? It should be 6. Let's see. 1, 2, 3, 4, 5, 6. Okay, I'm just going to do the horizontal and vertical one. Those are easy to count. Obviously, the hypotenuse would have the same relationship as well. All right, let's look at another example. Create a dilation of triangle ABC using the center of dilation at the origin and a scale factor equal to 1/3. Determine the coordinates for ABC prime. Why are the two triangles similar after this transformation? All right, so this time we have our original triangle. I already wrote down the coordinates for A, B, and C. So for point A here, it says the scale factor is 1/3. So don't I just multiply those by 1/3? So 3 times 1/3, I can do 3 over 1, make it easy. Does that give me 3 over 3, which becomes 1. All right, so that's going to be 1. And then when I go 6 times 1/3, I'm going to get 2. So it's going to be 1, 2. 12, 9, we do the same thing. We're going to multiply that by 1/3. So 12 times 1/3 is going to be 12 over 3, which is 4. 9 times 1/3 is going to become 9 over 3, which is 3. Okay. And then for C, 9, 6, 9 times 1/3 is 9 over 3, which is 3. 6 times 1/3 is 6 over 3, which is 2. All right, so then we take those coordinates, we plot our new points, and we can make our triangle. So here it is, right? We have the point 1, 2, we have the point 3, 2, and we have our point 4, 3. So you can see the dilated figure is smaller. It makes sense. The scale factor is 1/3. That's between 0 and 1, right? 1/3 is about 0.33. So that's why our figure is smaller. Okay? If I was looking at these two figures and we said, oh, what's the ratio of similarity? Well, if I just look at this side, 1, 2, this side's 2. This side, 1, 2, 3, 4, 5, 6. And so it depends if you want to go large over small, small over large. You just got to be consistent. So if I want to go large over small, I'd say my ratio of similarity is 6 over 2, which equals 3 over 1. Okay? If I want to go the other way, we went small over large, we would have had 2 over 3, which would equal, 2 over 6, which would equal 1/3. Would be your ratio of similarity between the two figures. Now we've learned in class, in our next part of this section, is we've learned that we need 3 corresponding sides that have that same ratio of similarity in order for those figures to be similar. So when we're usually working with this, we'd be testing all 3 sides. I'm not going to do that in the interest of time for this video. So that's it for our first lesson of this topic. Stay tuned for more videos coming up soon. Thank you.